70 million years ago, Earth was a planet of overwhelming abundance. Vast forests stretched from horizon to horizon, thick with towering conifers, flowering plants, and fern-covered undergrowth. Warm oceans wrapped the continents in humid air, feeding monsoon rains that nourished endless green landscapes. Dinosaurs ruled this world not only through strength, but through balance. Giant herbivores loomed like living mountains, consuming unimaginable quantities of vegetation, while predators followed carefully tuned patterns of survival. Life flourished because the systems that sustained it remained stable. Yet within this richness, a quiet force was gathering, one that required no claws, no teeth, and no massive body to reshape the destiny of the dinosaur world. Insects had existed long before dinosaurs ever walked the land. By the late Cretaceous period, they were already masters of adaptation, capable of rapid reproduction and astonishing resilience. Among them were ancient relatives of modern locusts, grasshopper-like creatures that thrived in warm, plant-rich environments. Normally, these insects lived solitary lives, scattered across grasslands and forest edges, feeding modestly and posing little threat to the larger ecosystem. Their numbers rose and fell with the seasons, controlled by predators, weather, and limited resources. For millions of years, this balance held. Then, the climate began to shift. 70 million years ago, Earth entered a phase of intensified climatic instability. Volcanic activity increased in several regions, releasing gases that altered atmospheric chemistry. Warmer global temperatures intensified evaporation, feeding powerful seasonal storms. Rainfall patterns became extreme, alternating between prolonged droughts and sudden, overwhelming floods. These conditions proved disastrous for many organisms, but for locusts, they created opportunity. Extended wet periods triggered explosive plant growth, covering plains and valleys in fresh vegetation. This sudden abundance provided ideal breeding grounds for insects capable of reproducing at extraordinary rates. Locusts possess a unique biological switch. When population densities remain low, they behave like ordinary grasshoppers. When numbers rise beyond a threshold, their bodies and behavior change. Hormonal shifts alter their color, metabolism, and instincts. They become social, restless, and driven to move together. In the late Cretaceous, repeated cycles of rainfall and warmth pushed locust populations past this critical point again and again. Egg beds hatched in the billions. Swarms formed not over weeks, but over generations, growing larger with each season. As these swarms expanded, they began to consume vegetation faster than it could regenerate. Entire fields of low-growing plants vanished in hours. Leaves were stripped from shrubs and young trees, leaving skeletal branches behind. Unlike large herbivores, locusts wasted nothing. They devoured grasses, seeds, bark, and even tough plant fibers that most animals avoided. Their feeding was relentless, continuous, and widespread. Wherever the swarms passed, green landscapes turned brown and lifeless. The first dinosaurs to suffer were the small and medium-sized herbivores that relied on soft plants and ground cover. Nesting grounds once hidden by foliage became exposed. Juveniles starved as food sources disappeared. Migration routes led not to refuge, but to further devastation. Larger herbivores followed, drawn by instinct to regions that should have supported massive herds. Instead, they found stripped plains and dying forests. Even giants such as hadrosaurs and ceratopsians, capable of processing enormous amounts of vegetation, could not survive when nothing remained to eat. Forests, the backbone of terrestrial ecosystems, began to collapse. Young trees failed to grow as seedlings were consumed before taking root. Mature trees weakened without undergrowth to support soil stability. Erosion followed, washing nutrients away during heavy rains. Rivers filled with sediment, altering waterways and flooding lowlands. Wetlands transformed into barren mudflats. The damage extended far beyond simple hunger. The physical structure of entire habitats unraveled. Predators soon felt the consequences. Carnivorous dinosaurs depended on healthy herbivore populations to survive. As prey grew scarce, competition intensified. Weak and injured individuals died first, but soon even dominant hunters struggled. Starvation spread upward through the food chain. Nest failures increased as parents could not find enough food to sustain themselves or their young. Territories once rich with life fell silent. The locust swarms themselves did not remain localized. Driven by instinct and shifting winds, they traveled hundreds of kilometers, darkening the skies as they moved. Sunlight dimmed beneath their bodies. Day turned briefly into twilight as billions of wings beat in unison. Their movement altered local climates, reducing temperatures below the swarms while trapping heat beneath them. Plants already weakened by consumption suffered further stress from reduced sunlight and airflow. Reproduction cycles accelerated the disaster. Locusts laid eggs in dry soil, waiting for the next rains to trigger hatching. Each generation grew larger than the last, unchecked by predators overwhelmed by sheer numbers. Birds, reptiles, and small mammals consumed as many insects as possible, yet made no measurable impact. Nature's usual controls failed against the scale of the outbreak. Over decades and centuries, the repeated devastation prevented ecosystems from recovering. Dinosaurs evolved for stability, for abundance, for predictable seasonal rhythms. They were not adapted to endure long-term ecological collapse. Egg-laying species faced declining success as nesting grounds vanished. Herds fragmented, reducing genetic diversity and weakening populations further. Disease spread more easily among stressed animals. Extinction began not with a single catastrophic moment, but with slow, compounding loss. In coastal regions, the effects reached the seas. Rivers choked with sediment altered marine environments. Nutrient imbalances disrupted plankton growth, affecting fish and marine reptiles. The collapse of land ecosystems rippled outward, destabilizing food webs across the planet. Life that had flourished for millions of years entered a period of decline driven not by a giant predator or celestial impact, but by an army of small, relentless consumers. By the time other global disasters approached near the end of the Cretaceous, many dinosaur populations were already weakened. Their world had been stripped repeatedly, their resilience eroded over generations. The locust plagues did not erase dinosaurs overnight, but they prepared the ground for extinction. They transformed a vibrant planet into a fragile one, where survival required rapid adaptation rather than sheer size or strength. The lesson written into this ancient catastrophe is profound. Dominance does not guarantee security. Even the mightiest creatures can fall when the smallest forces multiply beyond control. 70 million years ago, the dinosaur world learned this truth as endless wings swept across the sky, turning forests to dust and rewriting the balance of life on Earth.